Good evening, ladies, gentlemen, and esteemed guests. Welcome to the inaugural lecture of Prof. Carine Smith. On behalf of the Faculty of Medicine and Health Sciences Management team, I hope that you'll enjoy this auspicious occasion with us. I'd like to invite you now to stand as we observe the entrance of the academic procession.
You may take your seats. Good evening, colleagues, ladies and gentlemen. For those of you who don't know me, my name is Inaugural van Pitius. I'm the Vice Dean for Research and Internationalization of the Faculty of Medicine and Health Sciences of Stellenbosch University. It's my distinct pleasure, on behalf of Stellenbosch University, to welcome you all to this auspicious occasion. The professorial inaugural lecture of Professor Carine Smith. Goeienaand, dames en here, baie welkom by Stellenbosch Universiteit se Fakulteit Geneeskunde en Gesondheidswetenskappe. Dit is my groot plesier om u welkom te heet namens die universiteit. A special word of welcome to the rector, Professor Wim de Villiers, and the deans and vice deans of other faculties, and of course our inaugural lecturer this evening, Professor Smith. Welcome also to all family, and I saw number of the family outside, friends, colleagues, students of Professor Smith who are joining us here in person tonight, and also online, and including Mevrou Petrus Sedyn, Carine se ma, and our man Wynand, and the rest of the family. We also welcome our colleagues from Stellenbosch campus and all other guests from outside the university. Today we gather here to celebrate not only the remarkable achievements that have propelled Professor Smith to a well-deserved elevation to the full professorship, but also to honor the essence of intellectual curiosity and academic excellence that characterizes both her and our esteemed institution. An inaugural lecture is that time when you mark that specific moment in an academic's voyage as a scholar, as a researcher, as an academic, as an educator, a celebration of the ascent into the rank of full professor, providing the individual not only with an opportunity to present their academic pursuits, their research interests, and their passions, but also the contributions to their field of study, to the university community, and to the wider public. It also affords the audience to get a glimpse into the fabric of the person, their character, their path that they've traversed to attain remarkable distinction. It's a central part of our university's academic calendar, and it just epitomizes that pivotal milestone in any academic's journey. And as such, this is a very special event for us, for our faculty, and for the university. for everyone here present this evening. We are delighted that you have chosen to be part of this event, to share in the significance of this moment and this occasion with us and Professor Smith. So I hope you enjoy the evening, and I would like to now hand over to our Dean, Professor Elmi Miller, to please introduce the candidate.
Thank you, Niku, and welcome everybody. It's a real pleasure and a real honor to introduce Carine Smith to you tonight. Carine is a highly esteemed member of our faculty, the Faculty of Medicine and Health Sciences, holds a PhD in Physiological Sciences from our own institution, and is not only a respected professor in the Department of Medicine, but is also a fully qualified, trained medical technologist with the South African Health Professions Council. So Carine started off her life in Strand, close by to where we live today, and is one of our identical twin. So if you see somebody who looks just like Carine in the audience, it's not Carine. And she was incredibly in love with the sea, with the seaside, and she enjoyed every moment of that childhood. And I think it's difficult to imagine why would somebody like that end up doing research in zebrafish, but it was obviously meant to be. She told me that she considered for one moment in her career to actually do research around earthworms, but that was too much, and she then rather decided to focus on zebrafish. So she has been a really respected person in our faculty. She has a dynamic research group which is dedicated to disease modeling, and she's also working on drug discovery. As we all know, the zebrafish is a wonderful medium to look at that and a wonderful model, and I think she's going to tell us more about her pioneering work that is looking into chronic inflammatory conditions, things like rheumatoid arthritis and autism. So these are very important research projects that Carine is driving and is certainly respected for in the field. She is also a passionate advocate for research sustainability in Africa. So she is directing the Stellenbosch University Zebrafish Husbandry and Research Facility, which is also forming part of the Zebrafish African Network and expanding her research on the continent. She has about 98 peer-reviewed scientific publications, several book chapters, a patent in her name. So she really has made us all very proud, and I think her family very proud, with her really wonderful academic career and her positions on several boards and associate editor of several journals. So we are very honored, Carine, to have you talk to us today. We're looking forward to your lecture, and thank you for joining your insights with us. Thank you.
Thank you, Jan, and thank you for taking the time from your schedules to celebrate with me tonight. I think this must be the most difficult talk of my career because your family is notoriously the toughest crowd. Madame Curie was quoted as saying that a scientist in his laboratory is a child confronting natural phenomena that impress him as though they were fairy tales. And all my life, the new sights of nature made me rejoice like a child. These words really resonate with me, and I'm not going to give you a list of my accolades or tell you about all the papers I wrote. Tonight, I would rather just share with you a little bit of my journey through the work and the research that brings absolute joy to my life. And I hope you can, after this, understand why I just can't stop. So I grew up up in Strand, as Almi said. And when I was in school, I think I was what is called a pliggie. And I remember the career counselor saying to me, Carine, you can really become anything you want with your marks. They were a little bit surprised that I didn't want to study medicine, but that was never on the cards for me. I was interested in how this incredible machine that is the human body, how that all fits together. And the career counselor said to me, but whatever you do, just do not pick a job that will make you ever have to speak in public. So it didn't quite listen. So in fact, the first time, my first job as a medical technologist did hide me away in the lab. So that was in keeping with the shyness. And I thoroughly enjoyed the laboratory work for maybe 2-3 months, and then I realized how much automation has taken the excitement from away from lab work. And so despite my shyness, I put my brave boots on and I marched to the head of department, and I kind of demanded to be given something more stimulating. So after the poor guy recovered from his initial shock at the audacity of this junior staff member, he actually complied, and he sent me to work in what was called the bone marrow lab. And I remember it still freaked my sister out when she would call me at work and we would answer the bone marrow, hello. But this was the lab where we monitored leukemic patients. We did diagnosis and monitored treatment. And I basically became an unofficial research assistant to the clinician hematologists there. And this was fascinating. Looking at the different morphologies of cells made me just absolutely fall in love with microscopy. Again, being a junior staff member, I was frustrated by the fact that I wasn't involved in interpretation, and I wasn't allowed to provide input on follow-up experiments. And I realized that I would have to study further, not just in medical technology, but at the university. So I guess I was at the right place at the right time, because for a limited period of time, Stellenbosch University in the science faculty allowed Technikon graduates to apply for a master's degree in exercise science. Okay, so not an athlete, but still, I applied, got my foot in the door while I was still working at Tygerberg. And about a month after, I received my first student account, and I realized I could still not afford university. So that's the only thing an optimist, a brave optimist, can do, and I applied for a job at the university so that I could study for free. So that was my plan, and it panned out. I started working as a histology technician in physiological sciences on Stellenbosch campus. I finished my MPhil in exercise science. And although the whole sports arena was a little bit outside of my field of direct interest, it was amazing to see the human body perform at its absolute best in these elite athletes. I had amazing opportunities to meet these high-level athletes. Dubious honor of Peter Rousseau fainting in my arms after blood draw. I also did an oxygen consumption test in a 102-year-old athlete. So exciting times. But looking at all these athletes performance enhancement was not really my primary interest. But I was very excited or interested in learning about the toll, both mentally and physically, that high-level training took on these athletes. So after my master's, I was very fortunate to have Kathy Myberg as PhD supervisor, and she humored this somewhat different approach to her own. So I did my PhD, studied the interplay between the stress endocrine and inflammatory immune systems. And we did a series of human stress studies, both acute and chronic, physical and mental stress. And from that, I constructed a picture of the maladaptation that occurs in these systems in response to stress. And then as my PhD progressed, Kathy said, right, let's try your hand at modeling disease in a rodent model. And we basically simulated claustrophobia in rodents as a type of mental stress. And I've put this paper citation here, not because it was one of my greatest papers ever, but it was somewhere during this study where I remember a distinct moment where I did troubleshooting. And I had this moment where I said to myself, well, maybe I can do this. And I think that's where my love for disease modeling started. Also the excitement of being able to try out a treatment modality and seeing that abnormality normalize. This recipe is still the same. I still follow the same recipe today. I see a disease in humans. I model the disease or aspects of the disease in animals, and then obviously try to find treatments to normalize the abnormality. So shortly after my PhD, or I graduated from my PhD, I was appointed onto the academic staff, and I published this paper, which was quite a milestone in my early career. It was basically the insights that I've learned up to then. And what the novelty of this particular review paper is that we communicated this idea that inflammation has a good and a bad part. So the first excessive, potentially damaging part, and the second more pro-recovery part that should not be suppressed. And we published this in Sports Medicine, which was the #1 sports medicine journal at the time. And of course, saying to an athlete that you should not suppress inflammation created quite a bit of excitement. And a roller coaster of international talks, interviews for television, radio, all kinds of media. And today still, this paper is the paper that emanated from this department that has been cited the most times in the department, 102 years of existence. So it really made a huge impact. And I think I'm not saying this to you to tell you how great I am, because a lot of that was my supervisor. But I think what struck home for me is this idea that through research we can have amazing impact and really change the course of people's lives. And that is why I'm in this game, to make a difference. So, given my somewhat different approach to exercise from Kathy's, my research interest diverted a little bit from hers after I was appointed as independent researcher. And when I started lecturing at the same time, I realized that we had extremely high incidence of anxiety in our students. So I decided to make that my first research focus. Anxiety is, of course, a stress response in the absence of a clear and present danger. So it's very much in line with what I have been doing up to then. I was very fortunate to early on start up a collaboration with Professor Sidat in psychiatry on this campus. And that must be my longest collaboration ever. We published together again just the other day. But I really, in the early days, collaborated quite widely across different disciplines with many of you in the room. all the while studying the endocrine nervous and immune systems to see how chronic stress gradually facilitates maladaptation until you end up with a dysfunctional organ system. And then through a very fruitful collaboration with microbiology, I eventually added the microbiome as fourth regulated system, and with that also gut health, and in particular IBS as a comorbid condition to anxiety, to our research focus. I think because of the topic of stress, which will always be important, I soon became quite popular to the pharmaceutical industry as a researcher, and particularly in the ethnomedicine sphere. But I was a little bit exclusive. I really picked the candidate drugs which I thought had real potential. And my group has been working on these three for the past decade or so. And just briefly, we've been doing different things with different candidates. Scaletium tortuosum is a feigie, so it's a succulent indigenous to South Africa, and it's known to be anxiolytic. And for this compound, for which clinical trials have indeed also already shown its anxiolytic potential, but with some potential for risk, we've been refining the active components within this plant to get to a more pure, lower risk product. Then with grape extract, which is actually a product from the wine, recycled from the waste from the wine industry, we have linked anti-inflammatory function with a reduction in oxidative stress. We've already done 2 clinical trials using this intervention, and I think the most fun was actually setting up a model for arthritis in rodents, where we also were able to show some benefits of this particular compound. Rooibos is well known to all of you. We've also shown anti-inflammatory capacity for rooibos, but specifically in terms of the brain and the gut. So not only neuroprotection, but also benefits in terms of intestinal inflammation. That's in a nutshell the drug delivery, drug discovery type work that we did. And you'll see that we really go across many models, from cells to zebrafish, rodents, and even in humans. And I'm very proud of the fact that we are not stuck on one model. We are brave enough, once again, to go to use and to find a model that can answer the questions that we are asking. And I know it's a very in term to use to say that we can do bed to bed, bench to bedside. We can really actually do it. Something else, another opportunity that has come with the industry partnerships were all these events where we could communicate our research to the lay public and also industry stakeholders. I think very important to have this accountability in research, to show and communicate what you have been spending industry but also taxpayer money on. And it's a real skill to be able to communicate your science to the layperson. And it's a responsible task to communicate it in a manner that can benefit and not harm. And this is something that I try to encourage all my team members to do. And you'll see that is a picture from a recent, let's call it a roadshow, where they absolutely rocked it. Then a little bit related to that, where's Ingrid? I kind of want to duck when I say, when I entered academia, it was 100% to get to the research. That was the exciting bit. I was kind of caught by surprise when I realized how much I loved teaching. it's quite daunting the first day you stand in front of a room of 300 students rising up to the doorway at the back. And I'll never miss all the question papers that I had to mark. But it was a very fulfilling experience to see these young minds to develop, to first, stand in front of a room with stoic-looking students, not quite sure they want to be there, and then to first tease out interaction, and then see that develop into interest and later wonder for your subject. And that's been truly amazing to experience. In my own group, I have supervised very many students, and it's been an amazing journey for each and every person who comes through my lab, and it's become an absolute passion for me to take every person at face value, to determine their strengths, interests, and individual skills, and to build from that to the benefit of everyone. I have too often heard that researchers retire and that their whole niche dies with their retirement. And my aim is to build a team built on everyone's strengths so that that research thrust can outlive me. But let's get back to research. Einstein once said that we can't solve problems by using the same kind of thinking we used when we created them. So that water looks like someone drank from it. But I'm prepared. It's not a half jack. Like my fish, I drink water. So I think a little more than a decade ago, someone at the NRF must have seen these words of Albert Einstein. And the NRF put out this call for somewhat out-of-the-box creative projects called the Blue Skies Initiative. And I remember Kathy came to my office and she'd applied for this program and she failed. And she said, "Carine, why don't you have a go?" And at the moment I was talking to, remember I have my pattern of looking at the disease, modeling it, finding a treatment. And I was talking to microbiologist colleagues at that time, and they were talking about how antibiotics are becoming more and more toxic because of the superbugs that we have nowadays, and we were talking about how immune-mediated inflammatory disease treatments are becoming more targeted. And I thought, okay, 3 steps, let's just add a 4th step and think about drug delivery. And so we came up with this idea, and I have to just mention the Priya here. He's a molecular microbiologist who joined my group as a postdoc at just that time. And we came up with this idea. From my side, macrophages are immune cells that have this incredible capacity to stretch out these arm-like projections called pseudopodia to engulf any body-foreign potential pathogen, and then put it into this little vesicle called a phagosome, which then fuses with another organelle inside the cell to then digest and get rid of this potential threat. So I thought if we could just prevent this degradation or digestion step, I could put a drug inside the cell and keep it nice and safe until it delivered with no risk to the rest of the body. But the problem was how to get the drug released again. This is where Priya came in with his microbiology knowledge, and he told me about microbes with the capacity to escape phagosomes, to escape death, and to actually trick the cell membrane to make these little straw-like projections through which they can escape. And we decided that's what we're going to make. So that was our grant application, and I remember asking Marlene Fourier in the Division for Research Development, Marlene, is this blue skies enough? And she looked at me funny and she said to me, Carine, it's so blue, it's a bit purple. So we applied for this, and we were really very fortunate to get 2 full cycles of funding for the blue skies, meaning that I had 8 years of really good income to the lab. And I want to quickly tell you a little bit about this, because getting a substantial grant like this means it's really significant in terms of capacity building and technique expansion and just general creativity and excitement in research. So it was a very exciting period for my group. So basically what we decided to do is we would take a drug, which is a little blue ball. We would coat it with a nanomaterial that contains some of these microbial peptides which they use for escaping host cells. And we would construct what we called the synthetic microbe, okay? Because we wanted to sound blue skies. This we would then load into a macrophage. The macrophage would carry it to the site where it needs to be delivered, and once there, we would use these effectors to deliver the drug at the intended site. Okay, so we set off with on our route, and the first obstacle was the cost of these effectors. We calculated that we needed something like 3 or 4 million rands worth of effectors for the study. And it almost stopped right there. But fortunately, Dupriya was resourceful enough to synthesize these proteins for us in the lab. And in the process, he perfected a technique that was so novel and so cool, Niku, that we could patent internationally. And Dupriya is now running a spin-off company offering this service to other individuals. So we ended up with our synthetic microbe. For the purposes of visualization, we picked a fluorescent blue bead to simulate the drug, and then we added a red fluorescent coating containing our effectors around that. Then we allowed macrophages to ingest these beads, but we had to make sure that we had the right phenotype of cells. So we took human monocytes. We first heated them to specialize or differentiate them into macrophages, and then we had to still polarize them to make sure that we have the type of macrophage that would migrate from the blood into the tissue. So we achieved that. Then we had to make sure that this ingestion was via phagocytosis, because a cell can also ingest drugs or any other particle in many different ways, and we needed it to be in that phagosome. So we used high-resolution microscopy, and you can see there in the bluish picture how we captured a pseudopod extending to engulf that bead. And with time-lapse imaging, we could see the ingestion of these beads into the cells. Then, of course, seeing how many of these beads were in the cell, we were a little bit worried that they won't be able to squeeze through the endothelial cells lining the blood vessels. So we first had to confirm that they still have migratory capacity. So we simulated a blood vessel wall in cell culture, and using chemoattractants, we confirmed that our cells are suitably motile despite having this load. Okay, then, not the end yet, we had to allow enough time for the macrophage to travel to the site of delivery, because we didn't want the drug delivered prematurely. So for this, we had another cocktail of chemicals that we treated the cells with. And I'll play the video just now. It's basically showing a macrophage, and you will see that when phagosome maturation occurs, so when that digestive process starts, there's an increase in green signal that signifies acidification of the phagosome. And more or less at the same time, you will see that the fluorescent red coating will disappear from the beads as it is digested off. And that's just to show you what normal phagocytosis maturation look like. Okay. So then using flow cytometry, we could indeed show the red coating was disappearing and the phagosome became acidic. Then when we used our maturation arrest treatment, we could ensure that it kept the pH remained on the alkaline side and we didn't have any digestion. So this is how we knew that we had enough time to deliver our drug to the required site. And then the final step was the release. So the idea was that as soon as maturation arrest then starts, that activates the microbial effectors to first perforate the membrane of the phagosome, so that the effectors can escape, and then manipulate the actin framework of the cell membrane to make these straw-like actin spikes through which the drug was delivered. So when we got to this step, we really didn't have an idea of how frequent this process would happen or what the time frame is that we had to look at. So it was really difficult to do this with a microscope, where you can only visualize a few cells at a time. Fortunately, there was someone with similar issues than me in Professor she's Professor Sampson now from immunology, and we did a joint application to acquire an imaging flow cytometer, which came at the brilliant bargain price of 16 million rand. And this study was one of the first things that we did with the instrument. I think I have arrows. Yeah. So firstly, we could, so an imaging flow cytometer basically marries microscopy with high throughput cell counting so that you can end up with images of all your cells, but also quantitative data on what your, on what multiple hours of microscopy would have taught you. So it's a much faster, time-efficient method. So the first thing that we could show was that in the control group, the beads were ingested but didn't go anywhere. But with microbial effectors, the beads did not accumulate. So the assumption is that they were expelled. We could also see that even if ingested, these beads would marginalize around the cell membrane. And very excitedly, we saw that the cell membrane itself became relatively irregular. All of this pointed to expulsion of our drug. And we had quantitative data to back that up. Of course, now we had a time frame, so for all the doubters, we could also confirm using microscopy that we've indeed achieved what we set out to do. Okay. The next challenge was getting this published because it was so new that editors would write back to me and say that they cannot find reviewers who think that they're competent enough to adjudicate or evaluate this paper. So even though we finished the study and the PhD student on this graduated in 2020, we only got the paper accepted last year and published the beginning of this year. So sometimes there's a process. So I was promoted to full professor somewhere during the course of this Blue Skies work. So I could stop here, but I'm not going to. I first have to tell you about the new chapter, which has been an amazing journey all on its own. And I'm not going to tell you about everything I did on zebrafish because we'll be here till morning. But basically, I was looking for a new challenge after my promotion, and at pretty much the same time, Professor Essop, who who was a colleague in physiology and the president of the Physiology Society, suggested that I chair the local organizing committee to organize a physiology conference for that year. And after I said yes, they told me that it's a big undertaking with several societies and organizing a joint conference. But I don't think Fadil fully understand the favor he did by giving me that load of admin, because it put me in touch with Helmut and the rest of pharmacology, and we found a shared interest in getting the zebrafish unit established at the university. So we started, I'm not sure if I'm brave or stupid, we started this unit about 3 months before COVID struck. So yeah, don't try that. It was quite primitive and stressful in the beginning to keep everyone living. But I'm happy to say that now we really have great equipment, really high-tech analytical equipment, for which we really have to thank Niku and the faculty strategic fund. So one slide on zebrafish, okay? If you just look at them, you'll see why someone with a love of microscopy would just fall in love with them. They are in the larval phase fully transparent, so you can see life as it happens. And there is absolutely no way you can come into my lab, look at that, and not smile. It's absolutely amazing. The adults look like zebras, so they have stripes, but with a little genetic modification, you can also make them fully transparent. And this is where zebrafish really, I think, have an edge on all the other in vivo models, rodents and bigger animals, is that because of their transparency, you can label a protein or a system of interest. So you can take observations at protein or cellular level. You can correlate that with functional tests like vasodilation or peristaltic movements or even heart rate. And then you can match that to behavioral outcome, which gives you information on sickness behavior, anxiety status, overall well-being of the organism that you're working with. So you end up with a much more holistic readout in terms of research data, which is obviously an amazing tool to have in your toolbox if you do drug discovery research. So my current work is still on regulatory systems, but I'm not known for saying no to opportunity. So we keep adding regulatory systems to the list. Most recently, we've added the trace amine system, which is very similar to neurotransmitters, but they are related to the microbiome. We also collaborate with human genetics to look at genetic predisposition to some of our diseases of interest. And then because the literature up to very recently have been very male biased, while chronic inflammatory disease often have a strong female bias, we have also put quite a focus on also looking at sex as a predictor of outcome. Almost done. Just 2 slides to quickly tell you what our main focuses at the moment is. So we're still looking at gut-brain communication and stress and anxiety and effects that it has on gut health. But we have now moved further along to the point where we want to start to intervene and normalize some of these abnormalities that we see. And we do this in the context of autism spectrum, because as we know, mental health is quite prominent now, not only to funders, but also in terms of disease burden. And so we follow the same trusted recipe. We are profiling it in humans in terms of the trace amine signaling in particular, and we're working with the Neurodiversity Center under leadership of Dr. Ben Tritter. They have branches all over the country. So we're studying this disease in humans, and then in parallel, modeling autism using a genetic model for autism. At the moment, we have larval fish on the spectrum, and we are raising them to also do studies in adult autistic fish. And I just put a few pictures up here which really shows you the power of the model. So we can construct these very complex molecular profiles of the disease in the system of interest. For example, in the gut, and the alien-looking dudes on the right are larval heads seen from the top. And we can correlate it with behavior, which is what is depicted on the graph. And our working hypothesis is that we can intervene and change autism symptomology, not the disease itself, because that has a genetic basis, but autism symptomology by intervening to modulate trace amine signaling at the level of the gut. So watch this space. And the academic year day, there's some more stuff to come. And then something that I'm very passionate about, and that is the rheumatology-related research that we do at the moment. It's always been a bit of an interest in my group, but its progress was really hampered by the fact that we didn't have clinician input. And that fortunately changed with my move to this faculty. And the rate at which we accumulated critical mass, I think, is astounding to both me and Riet. So earlier this year, Riet insisted that we give ourselves a name now and formalize our activities. And so we established the Stellenbosch University Research in Autoimmunity Group, or SUNRAY. Credit to the, for the logo goes to Riet. And at the moment we are focusing on systemic lupus erythematosus. I'm just going to say lupus for short. And the reason we've picked this disease in particular is because people from African descent really shows a different disease profile from other global populations. So the disease trajectory looks different, and also their responsiveness to treatments developed in Caucasian patients. So this really is an African problem that we have to solve in Africa. And we're following more or less the same approach. We're profiling in humans. We're attempting model aspects of the disease in zebrafish. And we're getting ready to start with our treatment strategies. So again, lots of exciting things to come. And I think if I've learned nothing else, it is that inclusivity and cross-disciplinary research really just makes for a better end product. And I love working with all these different individuals with all these different skill sets. So that's my research up to now. And Kelly's going to burst if I don't tell her what the boost is for. So boost is basically an acronym for the 5 elements that I thought was vital in my career. So the B is for bravery. I think in academia we basically market our intellect, and we're supposed to boldly go where no man has gone before. So if you operate in this area of uncertainty, it takes a certain amount of bravery just to stick around, okay? Especially when times are tough. I have struggled with imposter syndrome for a long time. So imposter syndrome is that irritating little voice that keeps telling you, are you sure you're good enough to do this? And if it's related to your intellectual capacity, it's quite a sensitive issue. And for a long time, this has been a debilitating thing for me, always thinking I'm not quite good enough. Until Eric actually taught me to reflect every now and then. And I realized that this imposter syndrome, for me, is a sign that I'm operating at the right level of unknown. So when I feel this irritating little voice, I know that I'm at the frontier where a researcher should be functioning. So it's still there, still makes me breathe difficult when I have to speak to people, but bravery gets me through it. Then, of course, being a woman in science, and especially a mum, private life and a very preoccupying career can be quite a balancing act at time, and I think you also need some bravery to get through both of those. The first O is for optimism. I've heard students say that they pick me as supervisor because of my optimism. Again, we operate in an area where you don't get a daily pat on the back to say, well done. It's long from one student graduating to the next, or from one paper published to the next. So in order to stay healthy and motivated and enthusiastic in an area like that, I think takes quite a bit of optimism. Riet and I talked about visiting international labs and just seeing the scale at which international research is being conducted. And it's easy to become despondent when you see stats showing that Africa produces less than 1% of global research. But if you're an optimist, you look at the stats showing that Stellenbosch University counts under the top 2 universities in the world. And what that means is that even if we operate at a lower scale than international labs, we can still make our impact, even if at a lower or smaller scale. The correct way would be to say opportunism, right? But that kind of have a little bit of a negative connotation, so I just changed to opportunity because it's a very positive thing. I think in research, unless you do contract research where you can earn revenue, we are very dependent on marketing our offering to donors or grant trusts. And I think for this reason, if you're not an opportunist in research, you're going to struggle. You should not just take opportunity when it comes knocking. You have to go find it, grab it, and make it yours. Okay. Sometimes opportunity doesn't even look like opportunity. I've put a media picture up there because Anadi, who's also here tonight, and I did a study for an honors project 1 year, and the data looked good enough to write up. And a little bit after, I got a reprint request. And I sent it off, but for some reason that day, I wrote a personal note with this paper. And that led to communication, and later on a collaboration with a Spanish pharmacist, which led to 8 published papers, my first international keynote address, and co-supervision of a PhD student enrolled at a Spanish university. So it just shows you how sometimes something very small can become something very big. So keep keep your eyes peeled for those, because I really think the defect I have of not being able to say no actually works in my favor in this instance. I've already talked about the opportunities that the blue skies have afforded me. And the zebrafish is a topic all on its own, but it's been an amazing opportunity. And if I can just boast for 1 second, in the 4 years since I started the unit, and this includes the whole of the lockdown period, we set up the unit from scratch, being me and one postdoc at a time. I graduated 21 students, of whom 2 had graduated with PhDs, and we've published 10 papers from zebrafish-based projects. So if that doesn't convince you about the power of this model, then nothing I say can do that. But I invite you up to the lab. Brian still has to come. I promise you, if you can dream it, we can do it in a zebrafish. Then S is for support. And I think generally when you talk about researchers, they will immediately go to the funding. That's the support they need for research. And I want to differ from that. Although I would like to acknowledge the funders, whether they are here or online, thank you for investing money in research. But that is not, for me, the limiting factor in research. I think the biggest risk to a researcher, given the environment or the, let's call it uncertainty that we function within, is burnout. And for that reason, the environment where you work is extremely important. I have been lucky to work across 2 faculties, and I've been able to observe different management styles from very prominent female leaders in the Faculty of Science, as well as Helmut, Niku, and other individuals on this campus. And I could draw from those, and I hope that I have come up with a management style that creates an ethos of nurturing empathy and teamwork. Allow me to just single out Helmut for a moment. And I have to go down to read it so that I keep my bearings together. I want to single out Helmut for his absolute passion for medicine, his foresight, insight, ability to bring people together, and for really caring about the person behind each position in his department. Helmut, it's been a pleasure to work with you. The confidence you've placed in me has empowered me to achieve so much over the past few years. And I know that although you will leave a properly oiled machine when you retire later this year, we will miss your leadership and your deeply caring personality. Then, of course, over the years, I've had a finger in many pies, and I can't thank everyone who played a role there, but I have conducted a wall of fame, and it consists of individuals who have influenced the course of my career, also management and support staff who are worth weight in gold, and also those co-workers who, even though we don't work together, just a brief interaction with them just brightens up my day and makes me happy about the environment that I'm fortunate enough to function in. So thank you to all of you. And there are no prizes for the team. Research is a team sport. I've graduated many students and find great joy in seeing these young minds develop, while in return, I'm also learning from each and every one of you who came through my lab. So to all of you, I want to say thank you for this privilege. Generally, awards doesn't interest me. I measure success and career satisfaction by the joy that I get from the work I do. But there are exceptions, and there are two awards that is a treasure to me. The one is a very unofficial certificate that my postgraduates printed for me a couple of years ago, crowning me the best supervisor ever. And the other is the Vice Rector Award for Excellence in Postdoctoral Mentorship. And the reason why these awards are so important to me are because they were ultimately awarded to me by the members of my group. So guys, you are all amazing, and the trust you place in me is truly humbling, and I can't wait for the next decade. Of course, I also have a home team. So anyone brave enough to hug a cat like that has what it takes to stick it out with me, right? Wynand, thank you for being strong and gentle, for challenging me and also helping me to relax, for picking up the slack and the kids when I need it most, for loving me and for being proud of me. To my kids, thank you for loving me, for giving me purpose, for teaching me new things every day when I try to teach you things, for allowing me to have this amazing career, which sometimes preoccupies me, for laughing with me, for sharing my sense of humor, and for at least some days believing that I'm a little bit cool. This crowd is the Poppy Act compliant representation of the Van Edens, because there are many of them. Okay. So to all of you, I want to say thank you for welcoming me into your family, for becoming my family, for being there to supply anything needed, emotional support, advice, great food, many cups of tea, glasses of wine, and lots of laughter. Of course, I have to mention two special ladies. The one is Isel, who's been my friend for 46 years. Thank you for always being there and for reminding me to look after myself. I look forward to our next coffee date. And then my twin sister, Rihanna, or Kleinkie. She's called Kleinkie because she's a whole half an hour younger than I am. Thank you for being so like me and yet so different, for listening when I need to vent, for giving advice when I need to hear it, and for being my kid's weird aunt. And then lastly, Mum, I postponed my inaugural lecture for 6 years so that I can be sure that you can be here in person to witness it, because you deserve this event as much as I do. My success is also yours, and it's only possible because of the endless love and hours of hard work that you have put in over the years to get me here. So wat ek weet van liefde en harde werk, kry ek van ma af. En daarvoor is ek al dankbaar. Thank you.
Colleagues, I'm Wim de Villiers. I'm the Rector and Vice Chancellor of Stellenbosch University, and it's my job tonight, a very pleasant job, to provide a brief response and to over a certificate to our professor who delivered an inaugural lecture, Carine Smith. Wasn't that a thing of beauty? Wasn't that a beautiful story of the journey of science? So, professorial inaugural lectures at Stellenbosch University, it's a big deal. It's a big deal, and there's a reason why it is a big deal. Because it is a big deal in an academic's life. And an academic's life, as we clearly heard today, it is not a sprint. It's a marathon. And you need the experimental medicine arriving at the boost theory to understand that, what it requires to achieve success in an academic career, that it is a marathon. It takes 15 years to get to associate professor. It takes 25 years to become a full professor. It is a big deal. And what an inaugural lecture means, it is someone, a professor, professing that disciplinary expertise, sharing a career path, and also some insights. So that was beautiful. Thank you very much. So there were 4 words that were used that immediately grabbed me in this lecture. So I am the Rector and Vice Chancellor, but I'm also a gastroenterologist by training. So it was gut that got me. And then I achieved my PhD in immunology, in macrophage immunology. That got me. Macrophages, they're at the center of the universe. How can that not be absolutely outstanding stuff that's presented? And the third word that got me was inflammation. So the passion of my research life has been inflammation in the gut. And it's inflammatory bowel disease, whether it's Crohn's disease or ulcerative colitis, and bench to bedside models in rodents, in animal models of chronic intestinal inflammation. So therefore, when Carine approached me, she said she's got this animal model of intestinal inflammation in irritable bowel syndrome, and whether I would agree to be an examiner in a PhD thesis looking at zebrafish and irritable bowel syndrome. I've thought, what the heck? I know nothing about these critters. I know a lot about rodents, but I don't know about zebrafish. And I jumped at the opportunity. And what a wonderful, enlightening experience for me that was in furthering my continuing scientific education. So it was an outstanding PhD, very successfully defended. Congratulations on that. But don't let Carine tell you that she's shy, or that she lets an opportunity go wasted. Scarcely had the candidate successfully defended her thesis, then I got a request to fund a postdoctoral fellowship for that very same candidate, who is doing extremely well. So, not shy at all. So, I think what she clearly shows as well is the beauty of cell biology, of microscopy, of working in a wet lab, rather than what is nowadays, and I'm not diminishing the importance of that, rather than just in a dry lab sitting in front of computers all day. A wet lab is also the essence of science. The fourth word that was important to me that she mentioned was microbiome. Absolutely, that's where it's at nowadays. And we've got the African Microbiome Institute. We recruited some new people to our African Microbiome Lab. Did you know that so I'm a gastroenterologist, did you know that you have 100 times more bacteria living in your gut than you have total number of cells in your body? Doesn't that freak you out? Shouldn't we know more about it than what's going on there? So it was a real pleasure listening to your career, journey in your career, and the way you've inspired your students. And it reminds me a little bit, if I bring it back, to what Rutherford said, I think it was in 1918 or 1920 or so, when he got the Nobel Prize for physics. He said, all of science is physics. The rest is mere stamp collecting. But I want to say, as somebody who's a gastroenterologist and a physician scientist with an interest in chronic inflammation, that all of medicine is inflammation. The rest is mere details. So thank you very much and congratulations.
Thank you, Professor de Villiers, and thank you, Carine. What she didn't mention is she also gives very good parental advice. I was very worried my son started playing this game with witches and zombies and stuff. And I said to her, I don't know about this. She said, what is it? I said, Minecraft. She said, let him play it. And he loves the game. But anyway, thank you. Colleagues and friends, I trust that you found this event as enriching as I did and as captivating as I did. Thank you, Carine. It's a time to recognize the profound impact that our scholars make and that professors make on society and the world at large. So I think it was a wonderful testament. We also need to express our gratitude to the organizers of this evening for their hard work in organizing the event. Our sincere appreciation goes to the entire team from the Inaugural Lecture Working Group, as Megan Ceylon, Jonathan Dale Blankenberg, and members of the Marketing and Communication Division, whose meticulous planning ensured the smooth execution of the event. Our heartfelt thanks also to the colleagues from the Audiovisual Assistance Team, Campus Security, Facilities Management, Corporate Communications, Marketing, and the members from the Registrar's RC for their invaluable support, and everyone else who has made this a special event. So lastly, to each and every one of you, colleagues and friends, family, here in person, online, thank you for your presence here tonight to celebrate this occasion with Carine and with us. We greatly appreciate that, and thank you for attending. So I would now like to invite all of you to come and enjoy some light refreshments in the Dean's function area, just down the passage. Please enjoy the remainder of the evening and please drive home safely. Baie dankie vir almal wat hier was en ons waardeer julle teenwoordigheid. Please stand now for the procession to leave the hall.